Welcome to Xiaol.x. You're watching the overview of our next deep dive PretrainZero Reinforcement Active Pretraining. In this quick intro, we'll highlight 5 key impacts of the approach. 1. Massive sample efficiency gains. 2. Unified.
We just witnessed a 10-point explosion in AI intelligence, and it all comes from how we feed models data. Traditional pre-training swallows a storm of raw, redundant tokens. But look at this. Modern systems actively sift and reason, pulling out only the high-value signals. That's
shouldn't be. This new model achieves a shocking 10-point jump in reasoning performance, purely through self-play. No human teachers, no curated solutions. It outperforms standard methods by a margin we haven't seen before. Instead of relying on people to label data, it plays against itself, discovers its own mistakes.
Old way. Reading alone is slow. Our brains wander and comprehension stalls. Now imagine an internal teacher AI that doesn't wait. It attacks the student AI with the toughest questions it can find. Each strike forces sharper answers, faster recall, stronger understanding.
For years, self-supervised reinforcement learning promised to teach machines concepts the way we learn them. But in practice, it tripped over noisy data and latched onto typos instead of ideas. Now, a new approach flips that script, turning high-entropy tokens into a feature, not a bug. Here are 5 key impacts you need to know.
Welcome back to the deep dive. So if you've ever felt just, completely overwhelmed by the sheer volume of data that goes into training modern AI, well, you're definitely not alone.
You're in very good company.
Today, we are going deep into the engine room, really, of how large language models get built. We're looking at a pretty major shift in thinking.
A really fundamental one, yeah. It's about moving these LLMs from just passively, absorbing the entire internet,
right,
to learning actively, more strategically. Kind of like a Hume student who's actually trying to learn, not just memorize.
And our source material for this is a research paper, PretrainZero, Reinforcement Active Pretraining.
That's the one.
Yeah.
And it introduces a way to inject this really sophisticated reinforcement learning directly into that first huge pre-training phase.
And the key thing, I think, is that it does this using cheap, noisy data. Stuff like the raw text of Wikipedia, not some perfectly curated, expensive data set. Okay, so let's unpack this. Our mission today is to really get the mechanism behind PretrainZero. How does it let an AI basically write its own curriculum? And how does that boost its reasoning power right from the get-go?
We're going to break it all down. The problem they were trying to solve, the, I think, really elegant method they came up with, and then the results, which are, wow, they're pretty astounding.
Yeah, they really are. So let's start with that big question, the hook for all this.
Yeah.
Have you ever wondered why it's so incredibly hard to train an LLM for, general expert-level reasoning, even when it's already seen basically all the data in the world?
Well, the problem, it turns out, isn't really the amount of data.
Right.
It's the verifiability of that data and the density. I mean, how much of the web is actually useful, high-quality information versus just noise or redundancy.
And that's why, traditionally, if you wanted to teach a model some real expertise like deep skills, you had to wait. You did what's called post-training RL.
Exactly. Reinforcement learning after the big pre-training was already done.
The industry standard for a while was a method called RLHF. Reinforcement learning from human feedback.
And that was a breakthrough, for sure. It was great for aligning the model with, human values and what we want it to do.
But that alignment is so expensive. RLHF, it relies on actual people, human labelers, to sit there and rank the model's outputs.
And you just can't do that forever. You hit a wall, both a budget wall and a technical one. The model eventually just starts gaming the system.
You mean reward hacking?
Yeah, that's the term. It gets really good at getting a high score from the humans, but it's not actually getting smarter or more knowledgeable underneath.
So then to build real expertise, we got RLVR, right? RL with verifiable rewards.
Right. And that produced some incredible results. I mean, stunning, really.
Yeah.
But only in these super narrow specific areas, like solving math problems or writing code.
Because you needed a verifier. You needed a program, a compiler, or a math checker that could say with 100% certainty, yes, this answer is correct.
And that is the data wall. That's the bottleneck. Because if you want a model that can reason about, history or chemistry or philosophy, things where there isn't a simple right or wrong verifier, RLVR just doesn't scale.
So the goal is to take the power of RL, which we know can build these incredible expert skills, and move it. Move it from that narrow, expensive post-training phase into the big, cheap, massive pre-training phase.
Exactly. And that big idea is called reinforcement learning pre-training, or RLPP. But The first attempts at this, just applying a sort of vanilla RLPT to messy data like Wikipedia.
They failed.
Oh, they failed spectacularly because the noise is just too high.
Why, though? I thought the idea was to find the most unpredictable parts of the text because those would be the most informative.
That was the assumption, yeah. The idea was that high-entropy tokens, the most surprising words, must be where the knowledge is. But it turns out, in raw data, those tokens are usually just typos or random noise, not challenging concepts.
So the model was trying to learn from chaos.
And the whole training process would just collapse, which is where PretrainZero comes in with a totally new way of thinking about it.
It's inspired by active learning in people.
Yes.
Like if you're studying for a big exam, you don't just keep rereading the first chapter that you already know.
No, you'd be wasting your time. You go find the hard stuff, the complex, unfamiliar ideas that actually force your brain to make new connections. That's where real learning happens.
And that student analogy is perfect.
Yeah.
Imagine you're that student, and your textbook is the entire Wikipedia corpus. Just this gargantuan thing.
You need a system, something that can generate practice questions for you that are right on the edge of what you know. They have to be verifiable. You need an answer key, but also hard enough to make you think.
So PretrainZero makes the LLM choose those practice problems for itself.
Internally.
That's the magic. It builds its own curriculum on the fly.
So powerful. Okay, let's get into the mechanics of it. How does it actually build this self-teaching loop? It's structured as this dual system, right? A kind of competition. It is. It's a min-max objective, which sounds complicated, but you can just think of it as a teacher and a student inside the model who are sort of working against each other.
And they have to stay in balance.
A very delicate balance. They're trained together using an algorithm called GRPO, which is just a stable way to optimize this kind of adversarial setup over these massive, massive training runs.
Okay, so let's break down their jobs. First, the teacher. That's the mask generator.
Right. And the mask generator's goal is to minimize the system's prediction accuracy.
It wants the student to fail.
It wants to find the single hardest, most challenging chunk of words in the text to blank out. The toughest possible quiz question that is, in theory, still solvable. It's always pushing the student to the absolute limit.
Wait, hold on. The teacher's goal is to minimize accuracy. That just sounds completely backwards for learning. Why would you reward a teacher for making problems the student gets wrong?
Because it's not rewarding failure, it's maximizing difficulty. If the quiz is too easy, the student learns absolutely nothing. But if the challenge is just a little bit beyond what the student currently knows, that's the sweet spot. That's where the growth is.
I see. So the teacher's success depends on the student.
Which brings us to the student, the mask predictor. And its job is the exact opposite. It wants to maximize prediction accuracy.
It wants to ace the test.
It reads all the context around that really challenging blanked out text, and then it tries to figure out the missing words. But crucially, it generates its own internal chain of thought or reasoning process before it gives the final answer.
And if it gets it right, it gets a reward.
An exact match reward, yeah.
And the huge engineering leap here is that this whole system, this teacher-student dynamic, it trains directly on raw Wikipedia. So if I'm getting this right, it means they get to skip all the expensive, complicated stuff that other LLM training pipelines need.
That is the single most important takeaway. They don't need a supervised fine-tuning phase to get started. They don't need external reward models that were trained on thousands of human preferences. They don't need massive data sets of hand-labeled Q&A pairs.
They just use the text itself to create the questions and check the answers.
Exactly. They broke that verification data wall. It's basically self-supervised reasoning training. It makes general RLPT actually viable.
The model is teaching itself to reason better, just using the data it already has.
Yeah.
That's a really powerful idea.
Yeah.
Okay, let's get to the results. Because this is where it all goes from cool theory to, undeniable proof.
Yeah, the quantitative data it's really impressive. There are 3 demos in the paper that are just visually stunning.
Okay, let's start with demo 1.
Demo 1, the accuracy leap. So they took a solid base model, Qwen34B base, and ran it with PretrainZero against the old, simple, random RLPT baseline.
And we're not talking about a small improvement here.
No, not at all. It's like comparing a regular car to a Formula One car. The PretrainZero line on the graph just shoots up, consistently and dramatically outperforming the baseline on every single reasoning benchmark.
How dramatic are we talking? I mean, with these huge models, even a single point of improvement is a big deal.
Well, during pre-training alone, before any other fine-tuning, PretrainZero boosted the base model by 8.43 points on MMLU-Pro. That's a huge standard benchmark for language understanding.
Wow.
And on math benchmarks, the jump was even bigger, 10.60 points. This is a foundational boost baked right into the model's core knowledge before you do anything else to it.
That is genuinely astounding. To get that kind of lift in abstract reasoning from what is, at its heart, a self-supervised masking game, it suggests the model is wiring its brain in a totally different way.
It is, and that leads right into Demo 2, the consistent scaling. When you look at the graphs of the training process, the stability is what's so striking.
Right, because traditional RL can be all over the place, super volatile.
Exactly. The line for the random RLPT baseline just kind of bounces around, staying flat, but PretrainZero shows these smooth, steady upward curves, both its accuracy and, interestingly, the average length of its internal reasoning, its chain of thought, just keep going up and up.
So it's not a fluke. It's a sustained, real improvement in its ability to handle complex thought.
Which is the perfect setup for Demo 3, Guoqi emergence. This is the qualitative proof. This shows how the model's thinking has changed.
What did they show?
They gave it a task. There's a paragraph about a famous racehorse and the Triple Crown, and the word stakes is masked out.
Okay.
The old model, the passive learner, it just spits out the answer. Stakes, no explanation, no reasoning.
But the PretrainZero model.
Because it was trained and rewarded for solving hard problems, it performs this whole step-by-step analysis right in front of you. First, it analyzes the sentence structure, figures out the word has to be a noun. Then it looks at the context clues, Triple Crown, racing events, and it reasons its way to the conclusion.
It forces that chain of thought reasoning to just emerge on its own.
It emerges organically, which is exactly the kind of deep reasoning we want these models to have, and these benefits stick around. When you take this pre-trained model and do normal post-training on it, it still ends up being significantly better than a standard base model. It just starts from a much, much higher foundation.
It really sounds like the dream scenario. You get cheap data, massive scale, and you end up with superior reasoning. But we started by talking about the biggest threat to this whole idea, noise. You said other methods collapsed into chaos. So what's the catch with PretrainZero? How did they stop that from happening?
The catch is that inherent risk. You're using real-world, messy data, and the solution is all in the really clever, subtle design of the reward system.
Okay.
Remember those other attempts, like Entropy NPT? That failed. They failed because their teacher would pick tokens that were truly impossible to predict, just random noise. So the student would always get them wrong, get a 0 reward, and the whole system would just degenerate and collapse.
So PretrainZero needed a way to stop its teacher from picking impossible, unlearnable challenges.
Right.
It had to keep that balance of difficult but fair.
Precisely. And they built in this really smart defense. The generator, the teacher, is rewarded for making hard masks for low accuracy from the student, but, and this is the absolute key, if the predictor's accuracy on a given mask is actually 0, meaning the problem was literally impossible to solve, then the generator's reward is also set to 0.
I see. So the teacher only gets credit if the problem was solvable, even if it was really, really hard.
It only gets rewarded for finding material that is moderately challenging and verifiable.
It has to prove the material is actually learnable. It's incentivized to push the student right to the edge of the cliff, but not over it.
That's it, exactly. It's this beautiful little mechanism that forces the teacher to ignore pure noise, because noise is unsolvable and therefore yields no reward. That single piece of engineering is why this is the first method that can robustly apply this kind of active RL directly to massive, noisy data.
It really does pave the way for models that learn actively. They're generating their own curriculum.
The shift feels monumental, doesn't it? We're moving from models that just sit there waiting for us to tell them what to do to models that are actively seeking out the most knowledge-rich, challenging things they can find.
It fundamentally changes the entire paradigm.
And if just being smarter about how to learn from data we already have, like Wikipedia, can lead to these kinds of huge foundational gains in reasoning, well, just imagine the possibilities when an AI can actively decide what to learn next from the entire dynamic live internet, deciding its own growth path.
It really does feel like a new frontier.
A first frontier.